parabolic cable of a 60-meter portion of the roadbed of a suspension bridge are positioned as shown below. Vertical cables are to be spaced every 6 meters along this portion of the roadbed. Calculate the length of first two of these vertical cables from the vertex. So this is the given one, bridge. Right. Given PQ is the bridge with length 60 meters. PQ is the roadbed, that is the bridge. PQ is equal to 60, that is equation number 1. Let R be the midpoint of PQ. So PR RQ is equal to 30, right? So that is equation number 2. AB is the cable on which the bridge PQ is hanging. So AB is the cable, suspension cable. The bridge PQ is supported by the vertical wires. There are vertical lines in green, they are the vertical wires, right? Attached to the cable AB, such that the vertical cables are spaced every 6 meters along this portion of the roadbed. So distance between each vertical line is 6 meters, 6, 6, 6, 6, 6, right? All the green line vertical lines, the space, the distance between all green vertical lines, that is equal to 6. So let the extended PQ be the x-axis. Let us take PQ as x-axis and the extended OR, the center part, right? Center vertical line, right? OR. That extension line is y-axis, right? This is x, this is y. OR is equal to 3 is the shortest supporting wire, and that is what they have given everything, right? Also given that AP is equal to BQ is equal to 16. So let CD and EF be the first two vertical cables from the vertex, right? And to find the length of CD and EF, so these two EF, we want to calculate the length of the first two of these vertical cables from the vertex. So from the vertex we are taking CD and EF, right? Two vertical lines, right? That is two vertical cables or wire, right? So let CD is equal to B and EF is equal to C. So this is B, this is C. The coordinate of C is RD comma CD, x coordinate. So because O is the center, means RD is the x distance, right? And CD is the y distance. So C is 6 comma B, right? If you are taking a tangent at O to the parabola AB, then that is the axis, right? So now we are taking a PQ as the x-axis. So R is the origin here, right? Instead of O, you have to take R, because the point of intersection of y-axis and x-axis, R is 0 comma 0, right? That is why RD and CD is the that is coordinate of C. So RD we know 6 and CD is equal to B. So C coordinate of C 6 comma B, but clearly C is lies on the cable, right? And we are taking RF which is equal to RD plus DF, each 6, right? 6 plus 6 is equal to 12. Coordinate of E is RF comma EF, that is 12 comma C. Clearly CE is also on the cable AB, the parabola, right? The coordinate of O is, because R is the center, 0 comma 0. So O is at y distance 3 from R, right? So 0 comma 3, y axis on y axis, right? So O is 0 comma 3. Let us draw the diagram again, right? right? COC. We know the required equation of the parabola, the given equation of the parabola. This is open up, right, with vertex h comma k, and y-axis is the axis, right, open upward, right. X minus h the whole square is equal to 4a into y minus k, because vertex is different for the parabola. Origin is r, right, 0 comma 0, but vertex is o, 0 comma 3. That is why h comma k we are using that formula. Hk is equal to 0, o 0 comma 3. Hence the equation of the parabola is given by x minus 0 the whole square, which is equal to 4a into y minus 3. X square is equal to 4a into y minus 3. That is equation number 3. Now the coordinate of B is RQ comma BQ. RQ, the distance is 30 and BQ is 16. So 30 comma 16, right? Clearly B is on the parabola, right? 3. So substituting the value of x is equal to 30 and y is equal to 16 in 3, we will get 30 square is equal to 4a into 16 minus 3. So 900 is equal to 52a. A is equal to 225 by 13, right? We can cancel 900 by 52. So you will get 225 by 13. That is equation number 4. The point C 6 comma B is on the parabola, that is on the cable, right? Cable is nothing but parabola. That is equation number 3. So substituting x is equal to 6, y is equal to b in 3, we will get 6 square is equal to 4a into b minus 3. Substituting the value of a, 6 square 36, that is equal to 4 into a value 225 by 13 into b minus 3, right? So 9 is equal to 225 by b by 225 by 13 into b minus 225 by 13 into 3. So you will get 225 by 13 into b is equal to 792 by 13. So b is equal to 792 by 225, that is equal to 3.52. That is equation number 5. Now the point E 12 comma c also lies on the parabola 13. Put x is equal to 12 and y is equal to c. So 12 square is equal to 4a into c minus 3. 144 is equal to 4 into 225 by 13 into c minus 3. So c minus 3 is equal to 144 by 4 into 13 by 225. So c minus 3 is equal to 144 by 4 into 13 by 225, that is equal to 2.08. So c is equal to 3 plus 2.08, that is equal to 5.08. Since the required length CD, that is what we have to find, 3.52 meters, and EF, that is the length 5.08 meter. Thanks. Next problem. Assume that the water issuing from the end of the horizontal pipe, the ground, describe a parabolic path. The vertex of the parabolic path is at the end of the pipe at a position 2.5 meter below the line of the pipe. The flow of water has curved outwards 3 meter beyond the vertical line through the end of the pipe. How far beyond this vertical line will the water strike the ground? We'll see. Given water issuing from the end of a horizontal pipe 7.5 meter above the ground, right? Describe a parabolic path. So this is the horizontal pipe. So water issuing, right? Water is in the orange color, right? So horizontal pipe, this is the water, right? So end of the pipe, that is, right? So if you are if it is other side, then it will be make it a parabolic curve, right? Dotted line, right? According to our imagination, we are completing that parabola, right? This side we are using the dotted line. So this is the ground x-axis, this is the y-axis, right? Let V be the vertex of the parabolic path at the end of the pipe. So end of the pipe, V is the vertex, right? Given water issuing from the end of the pipe at 7.5 meter above the ground, so OV, right, that is the height from the ground, water issuing point, right? OV is equal to 7.5. The coordinate of V is V is 0 comma OV, right? Because it is on right, on y axis. V is on y axis, so x coordinate 0 and the y coordinate is OV, that is nothing but 7.5. so coordinate of V is 0, 7.5. Given that 2.5 meter below the line of the pipe, the flow of the water has curved outwards 3 meter beyond the vertical line. So through the end of the pipe, right? So let P be the point which is 2.5 meter below the pipe. So we are choosing a point, the vertical line, which is 2.5 meter below the pipe, right? Such that the distance between P and the water path, so orange, right, is 3 meter. So this is, let it be Q. So this distance PQ is 3 meter. That is 2.5. This is 3 meter. So VP is equal to 2.5. PQ is equal to 3. Now OP is equal to OB minus VP. That is equal to 7.5 minus 2.5. That is equal to 5. Let A be the point at which the water strikes the ground. So this is the end point. We know that the equation of the parabola with vertex h, k and axis of symmetry is y axis open downwards. The equation is x minus h the whole square, which is equal to minus 4a y minus k. Vertex is v, right, h, k is 0, 7.5. Substituting the value, the equation of the parabolic path is x minus 0 the whole square, which is equal to minus 4a into y minus 7.5. That is x square is equal to minus 4a into y minus 7.5. That is equation number 1. We are drawing again, we are because we need the diagram, that is why, right? Now here OB is equal to PQ, which is equal to 3, and QB, which is equal to OP, is equal to 5. The coordinate of Q is OB, QB, right? That is 3, 5 coordinate of Q. But Q is on the parabolic path, right? So it is on the parabola 1. Substituting x is equal to 3, y is equal to 5 in 1. So 3 square is equal to minus 4a into 5 minus 7.5. So 9 equal to minus 4a into minus 2.5. So 9 equal to 10a, a is equal to 0.9. That is our 9 by 10. That is equation number 2. To find the distance OA, that is what our required distance between the vertical line and the water strike the ground, right? Now let OA is equal to B, right, this distance. So the coordinate of A is OA, 0, that is B, 0. So but A is on the parabolic path, that is equation number 1. Substitute x is equal to B and y is equal to 0. So we will get B square is equal to minus 4a into 0 minus 7.5. So B square is equal to minus 4a into minus 7.5. B square is equal to 30a. But we know a is equal to 9 by 10 from equation number 2. B square is equal to 30 into 9 by 10. Right? So B square is equal to 27. That is equal to 9 into 3. 3 square into 3. Therefore B is equal to root of 3 square into 3. 3 root 3 meter. Right? Hence the required distance is 3 root 3 meter. Thanks.